good morning, or perhaps even good afternoon to all the attendees of this webinar on Inca AptiTune GO with a subtitle Heavy Duty Tuning for the Light User. The webinar will be presented today by Leon Ariaans, who is the APC Technology Manager of IPCOS. So there is also a possibility at the end of the presentation to raise some questions, so you can also do that during the presentation, of course. The idea is that there is a chat box to the right bottom side of your screen where you can fill in all the questions. They will pop up here on my screen, and then later on we will take care of all the questions. So don't hesitate to raise your questions even during the session.
Thank you, Christian, and good morning, good afternoon, everybody. In this presentation, I'm going to first make the case for tuning tools, automated tuning tools, and I'll then take you through an example all the way from step test to new tuning parameters using Inca AptiTune, the regular Inca AptiTune that some of you may know already. And about halfway through the presentation, I will take the tuning exercise from the local installation of AptiTune to the cloud and show you what the same exercise looks like if you execute it using our cloud-based offering. Have a look at what's the same and what's different. I have a few words about availability of the cloud offering and when it might or might not suit you, and compare in the end the two AptiTune offerings that we have. But let me first make the case for tuning tools. If you are tasked with the assignment to tune the loop, to improve the tuning of a certain PID loop, then your first experience might have been that you do that using trial and error. You increase the proportional action a bit and see what that does. Find that the end error doesn't go to zero, so you increase the integral action a bit. Then you become enthusiastic from the results and you increase things even a bit more. Things start to oscillate, may even go out of hand. And that might be a trigger to say, well, maybe a more structured approach is appropriate. And then you might switch to tuning methods like Ziegler-Nichols or Kappa-Tau. And what these tuning methods have in common is they provide a structured approach to tuning. They take you to a set of steps. And in those steps, either explicitly or implicitly, a couple of process parameters in combination with the loop you are using are established. And based on those parameters, you come to values for the tuning parameters in your PID loop that give you a certain behavior. Now, if you do this work more and more, an experienced project engineer, experienced control engineer can give you an estimate of what the proportional gain should be like if you tell him what the gain of a certain transfer, a certain curve is. If you increase the valve position by 1%, if you tell him what that does to the flow, he can give you an indication of what the proportional gain is going to be already. And based on the speed of the response, he can give you an indication of what the integral time should look like already. So based on experience, you can come to a tuning upfront already, given these pieces of information that I mentioned. But things start to get a bit laborious if you want to trade, say, overshoot against tracking behavior or speed of response. And that's where tuning tools can be useful. They allow you to make explicit what kind of balance you want to strike, and then these tuning tools give you the loop parameters that are corresponding to that balance that you have specified. AptiTune can work in that setting using single loops, but the distinguishing feature of Inca AptiTune is that it can also work with multiple loops. The approach you often see when multiple loops are being tuned is that loops are being tuned one by one. But if there is an interaction between the loops, this interaction is not taken into account, and if you change one loop, it might affect how you would want to tune the other loops in your overall picture. That's where Inca AptiTune comes along, or in particular where its multi-loop tuning capabilities are most relevant. So I'm going to take you through a tuning example using, well, a simulation of a distillation column. The example I will be using is an example that we also use during our PID tuning course. This tuning course is not focusing on the tuning tools. It's at a more general level that it instructs how to do PID tuning, but it uses AptiTune or Inca PID tuner. And to support doing exercises with the tuning tools or also manually, we have a simulation example, or we have a couple, and one of them is a distillation column that is actually a debutanizer. This distillation column gets its feed here, which is a natural gas liquid feed, a mixture of those. And the idea is that the butane and the lighter components are extracted from the top. C5 and heavier components go through the bottom. There is a reflux drum where the lighter components, then butane, are extracted as off gas. And what we will be focusing on is first the flow controller that controls the reflux flow. This operates on the valve in this reflux pipe, but we are using this also in a cascade construction. If you increase the reflux flow, it's going to lower the temperature in the top of your distillation column, so you can use the set point of the flow controller as the handle that a temperature controller is going to use, and that's the cascade construction that we are using. So TC001, that's the temperature controller for the top. Its output is the set point for the flow controller FC003, and that flow controller is manipulating the valve in the reflux stream. Now let me bring you the simulation example. So I'm not going to go through all the knobs you can turn in the simulation example, but similar to a real life experiment, there's a couple of things to take note to do or to prepare for the step tests that you will be executing to support the tuning tools. Most of these tuning tools, and AptiTune is no exception to that rule, they start or they require you to do a step test where you collect the responses of the so-called dependent variables to your independent variables. Then you go through an identification exercise which gives you a model, and then that model is used for the subsequent tuning. Now, to do this tuning exercise, the loop that the inner loop, the slave loop, needs to be put in manual. At this point, we need you to do open loop experiments. And if you are thinking of what should this experiment be like, there's a couple of questions you need to answer. One is, how big am I going to make my steps? Well, we have a reflex valve that is in its normal position, say at 60% open. We're going to open this for 2% more. You should make sure that the step you make here is big enough to have an observable influence, a clearly observable influence at the, in our case, the reflux flow, the top temperature on the one hand. On the other hand, the step shouldn't be too large to upset the column too much. So that amplitude of the step is one thing to consider. The other thing to consider is how long is this step going to take? Well, a step of about 800 seconds will turn out to be adequate for our purposes. So first we go 2% valve position up from the nominal value of 60. We leave that be for 800 seconds. Then we go down all the way to 58. So we take a step of 2 down compared to the nominal position. We leave that be for another 800 seconds. Then we go back to 60, and then we collect data for 800 more seconds to observe that final response. Now this amounts to about 47 minutes of time, of real time. If I would run this on my laptop, it would take about 2 minutes. It's still faster than 47 minutes, but I'm not going to let you sit through that. I prepared this, or actually a coworker of mine prepared this data already, and I'm going to start from this model, from this data that was collected then. One other thing that you would take note of when you would do this in practice is what are the current tuning parameters of the loop, and here the reflux loop, you see which tuning parameters were entered there, and for the top for the temperature controller, top temperature controller, these are the current parameters. You can record these parameters and enter them in AptiTune later, so that you can compare the response that the new tuning gives you to what the original tuning would have given you. So we've now done this identification experiment, and we now move to AptiTune. So let's make a project. Yeah, as Christian mentioned, indeed this is the desktop version of Inca AptiTune. I'm going to overwrite this experiment. I'm going to start with an empty one. There's no signals, no tuning. So we start from the top. And we now need to import the data that was collected previously. So for that, we're going to use the Inca import wizard, which is conveniently showing up on my other screen. The import wizard supports importing data in various formats. Now the format that is used quite a lot is text format. That's also the format that was used in the simulation example that I just indicated. So let's have a look at what that data looks like. The wizard needs you to explain what the format of the data is, and the first thing it needs to know, how are the various pieces of information separated? And there's basically two types of information in this file. One is the timestamps, when was the measurement taken, and the other is what is the measurement that applied at that time. So these are comma separated value. As you can see, the columns seem to be split in a sensible way. The encoding is for when your file uses non-ASCII characters, so it uses, for example, degrees centigrade, etc. Unfortunately, there's technical complexities there that determine how things are interpreted there, but if you stick to just numbers, letters, and not too exotic symbols, US ASCII is going to be fine. Which takes us to the next page in the import wizard. One thing we must specify is what is the name of the variable that we are importing. That is required, but additionally you can also say, if your file includes it, I have a description of the variable, in this case on the third row. Third row happens to be the same as the first row in our case, but we could have put a longer text description there and imported it like this. And it's usually also convenient to have the correct engineering unit available, and we can specify here that that is in column number 2. Then we come to the part where the wizard needs to know how to interpret the timestamps. It assumes by default that the timestamps are in the first column, which happens to be correct, and it has a lot of time formats that it knows about, and it tries to match these to the text that it finds in the first column. And the ones that actually match, it puts that on top. And in this case, there's 4 that match. Now the question is, was this data collected on January 11th or on November 1st, 2017? Well, I happen to know that it was January 11th, so the selection here is correct. Otherwise, you would have to take the one a few lines down. Let's forget about time zones for a moment and go with the defaults, and then we are almost there. We have an opportunity here to say I don't want to import all the data but only these few columns, but for now we're just going to import them all. And while importing, it is not required that the data is available, is sampled at a fixed sampling rate. It's what you typically have, and I do recommend doing that. But during the import, you can say, well, you might be missing a sample or two. I want you to resample it at this sampling rate. And in this page, we tell the wizard, you go decide for yourself what you think is the most appropriate sampling time. That's what we do here. which finally takes us to the import of the data. And well, we have no warnings, no errors, so that seems to have succeeded. Now, what have we achieved? What can we do with this data? Let's first have a look at a trend of the data. Inca AptiTune has powerful trending capabilities. If I plot several signals at the same time, it initially chooses the same y-axis for all the variables that we're looking at, which happens to be not that far apart in this particular case, but you can imagine that your process value is in an entirely different range than your OP value. So what you would often do is specify that your set point is using the same scale as your process value, as your measurement. That's what I just did. And then say, and now give every signal its own axis. And if I then zoom in, you can see that the experiment that we did, the OP value makes these moves. It's nicely spread out on the y-axis, and on the axis below we see the response of the flow. Now I'm showing a signal that's called set point for the reflux controller. Remember that we did the experiment in open loop, so the set point is actually on top of the PV value, or you could also say there is no set point. The set point value is not that relevant for us. The flow value is for our purposes, and well, as you can see, there is a clear response to the steps that we have applied. And if I also drag in the top temperature, you can see first that there is a clear response that exceeds the noise level. That's one thing. The other thing is the steps seem to be long enough to allow the signal to stabilize. It's not necessary that you wait until it's completely stabilized, but it's a good thing if you see it stabilize so that you can visually inspect and get a feel for what the model is like. Okay, now with the models or with the data ready, we can start modeling, and for that we have to specify a case. Let's call that case DC top case. And what a case involves is it specifies what the independent and the dependent variables of your model are. The independent variable, that is the variable that I have been manipulating, so that's the output of the reflux controller, the valve position, so let's select that as the independent variable. And the two dependent variables are the reflux flow and the top temperature that are the response of this. So this describes, say, the shape of our model. There's one more thing that we need to specify, and that is what is the algorithm that we want to use. Well, FIR is going to be, FIR is going to be sufficient. We're going to use a sampling time of 10 seconds, which might be a bit large for our temperature loop, but for time reasons I'm going to do it with one sampling time here. I'm going to specify 80 coefficients and leave the smoothing factor for now on its default value and see what that gives us. So we see two models. AptiTune always gives you a constrained and an unconstrained model for every trial. And if we first look at the top temperature response, we see a nice response, not too many wiggles in there. Quick sanity check, if you open the valve further, the temperature drops. That seems to make sense. So this seems to be okay. But if we switch attention to the reflux model, specifically the constrained one, the smooth one, we see that there's quite a bit of a difference between the constrained and the unconstrained models, and that has to do with two things. One thing is, for a model that is relatively fast, the effect of smoothing on the model can be a bit large if you stick with the default value of 5. If I put this at 0.5, it's going to make a difference already. The other part that is making quite a difference here is, by default, AptiTune is going to assume that if I apply a step to my valve in this case, the flow is not going to respond instantaneously. It's going to be fast, but it's not going to be immediate. But if you look here at what happened in the first sample, we missed quite a bit of the response already. So if we correct that assumption and run the whole experiment again, you see that the model fits quite nicely also in the constraint case. And this is the model that we're going to use for tuning. I did one trial having one sampling time for both curves that I need. AptiTune is more flexible, and in fact if you would do this, and we're not trying to do two of these experiments in one webinar, I would recommend doing this with a faster sampling time, smaller sampling time. But for now, let's go with this, and let's construct the model based on this constraint model. As I said, you can pick curves from individual trials, different trials also, but in this case I'm just going to use all the curves of the constraint model, and this is going to be the model that I'm going to be using for my tuning. Now we've reached the point that we finally start tuning, so I'm going to add a tuning case, call that TC top also. I have to pick which model to use, but I have only one model matrix, so that's a simple selection. The other thing you need to specify here is what is the brand, the manufacturer of your DCS. Different DCS vendors implement their PID loops slightly differently, and they call their parameters and scale the parameters of the loops slightly differently. And AptiTune has support for PID loops you encounter in all common DCS systems, but you have to pick the right one to match the DCS that you are actually using. Now, in this example, we're not using a specific vendor, it's a simulation example, so I go with generic, which makes a first selection of the equations that are available. Once again, all these equations are very similar. You can obtain very similar results using one DCS manufacturer or the other, but the templates are different. We get to see different equations within the same manufacturer in a few minutes. Now when I open my tuning case, I have the opportunity to give the loops or the controllers a more sensible name. So let's call the first loop, which is the flow controller FC, and the second, which is the temperature controller TC. Now there's still one thing not quite right. AptiTune sees that our model has one independent but two dependents, yet I'm using two loops. And by default, it's going to assume that there's no cascading relation between these two loops, so it would have expected two independent variables. But as soon as I point out to AptiTune that the temperature loop is the master of the flow control loop, these exclamation marks go away, and I come in the screen in which I can set a few parameters. Now, the first thing to set is the type of equation that we are using, and the difference is the P or the D action, is it acting on the error or is it acting on the measurement? Now this first one, P and I are on the error. I is always on the error, and I want my times to be expressed in seconds. That we switch the D off to keep things simple initially. This loop is I on error PD, and let's switch this also off. And because I cut this corner and have a relatively long sampling time, the default value for the delay margin that AptiTune has chosen is a bit optimistic. It has an immediate response in its flow control, and it further says I'm not going to be robust for any variation in the dead time there. That's probably a bit too optimistic. This is going to lead to too aggressive control. So let's set this to 1. One final thing to look at when you do this for real is, are the PV and OP ranges correct? Well, from 0 to 100, that's correct in this case. So let's do a first run of tuning. Okay, we'll come back to this in a minute. It's usually a good idea to see, if you run this experiment once more, if the parameters stabilize and if they come to the same point, because AptiTune occasionally zooms in on certain behavior, but if you give it a few more runs, it converges better there. Well, as you see now, the variables don't change anymore. So if we now look at what the responses look like, we see that our temperature control is our flow control is a rather fast one, Our temperature is a bit slower. Well, there's more to be said about this tuning, but I think it's now about time that we take our demonstration to the cloud. So let's see how this same demonstration, what this looks like if we take it to the cloud. And I'm going to jump straight into the cloud. I'm going to show you how to get there, but you're looking at a browser window. This is Internet Explorer, and in this browser window I've already started Inca AptiTune. Ignore for a minute this countdown that says that I have 4 hours and 90 minutes left. I'm going to go through the same moves in the cloud, and we're going to see what the difference is. Well, let's start from scratch with an empty project. And one thing to point out is here in the cloud you are basically accessing a Windows machine that is running at an Amazon server, and on this Windows machine that you are accessing through your browser, there's basically 2 folders in which you can put data. There's the home folder and the temporary files folder. The temporary files folder, as the name suggests, it contains files that are only temporarily there. If I log off from this session and come back in a week's time, all the files I put in temporary files are gone. But the home folder keeps the files I store in there. So if I put a TC Top project in there for AptiTune, it will be there later on. Now I want to import this data, but first I need to get the data that I collected into the cloud, and there's this up and download button over here that we can use for that. So if I go to home folder, you will find a couple of files that are there already, but it also allows me to upload the experiment file that I collected earlier. So if I now go through the same import wizard, select text files, and I am in the home folder, you see the same files here. So this is how would you approach it in practice. You would upload your CSV files and take it from there. Now I'm going to rush through the import. I'm not going to explain what all is about because it's the same as what I previously showed in the desktop version. These defaults are correct. So here's my data. Now there's one thing that I want to point out at this stage. You can slice data here and exclude it from your optimization. You can access this browser, you can use the browser on your tablet to access this as well. But the slicing of data, and there's also other operations that require dragging and dropping, as I'm demonstrating here. That dragging and dropping might be troublesome if you are using a touch interface only. So I would recommend using this from a desktop browser so that you have that drag and drop functionality available. Now let me go through the identification steps again and come to the tuning. Finally come to the tuning. Hang on. Close and one more.
So look at these, just identify.
Yeah. And let's go to the smoothing and direct transmission in one go. There we have it again. Let's make a model matrix. Easy up model. Yes, please. Your tuning case, DC top. It's a generic controller. It's the right model. Okay. Let's see. Not to get confused. DC. Okay. So let me make the manipulations that I made previously quickly, take us to the point where we were when I left the desktop environment. Let's make these settings identical. quick check. Did I catch everything? Yep, I did. So let's tune. And let's observe. Let's give it a chance to converge. One more time just to be sure. Now, these are step responses very similar to what we've seen before, and let me highlight at this point, well, let's not highlight at this point, there's parameters to play with here, but maybe it's good to show you, instead of playing with these parameters, what it looks like if you want to access this, if you want to get here from the beginning. At this point, it's important to realize that the AptiTune that you saw me use from my desktop, it's the same AptiTune with the same functionality in the cloud environment, so it has the same functionality. If updates are made to one, you will get updates to the other. So let's move to the part, is it available, what do I need in order to use this, and I will be switching to my presentation again for that. Give me a minute. And the other way around. So AptiTune available, AptiTune GO, the cloud offering, is available now, and as I mentioned, you need to have a modern browser. I demonstrated using Internet Explorer. It works on Firefox, it works on Chrome, it works on Edge, it works on Safari if you are on that operating system. So all modern browsers are supported. As I pointed out, you would do good using a mouse to use all the functionality comfortably. And we haven't encountered ourselves yet that firewalls block access to the Amazon cloud, but this is running in, well, what Amazon calls the UE West 1 location, which is Ireland. And if company or hotel firewalls are very aggressive, it might be that they block access to the Amazon cloud. You can try that before you buy Inca AptiTune by signing up for a trial account at Amazon and go to the link that I provide here. There they present Word, well, a couple of other applications that you can try, and if it works there, if these applications work for you, then AptiTune is going to work for you also. For that to work, actually, you need to buy tuning time online. You saw this hint in the, or this countdown at the top that says how much time I have still available. This tuning time you can buy in our web shop, and let me show you where that is at. So the fastest way to get there, this is our homepage, is that you search for shop. And the first hit is the one that you need to have. And if I go to the offering here, I can explain in a bit more detail what the offering is like exactly. We offer hours of tuning time at a rate of 75 euros per hour. With a minimum of 8 hours, and if you currently buy 8 hours, we give you 2 hours for free, so you get 10. It is important to notice that the validity of this tuning time is limited. It's limited to 6 months at this point, so if you buy it now, make sure to use it in the next 6 months. If that is a problem for you, do get in touch with us, but we want to keep the flexibility to move to different cloud providers or to make other changes there, so keep that in mind. So if you go through this process, put these 8 hours in your card, you have the option of paying either by credit card or by bank transfer. You will get immediate response and immediate mail from our website. We will send you an email with a proper invoice next. and in that email we will also announce that you will get an email from Amazon that says that an account was made for you that you can use to access Inca AptiTune GO. And this email of ours also indicates what the sender of that Amazon mail is going to be, so you can make sure that this message is not ending up in your spam folder. Now, let me try and show you what the logon experience looks like. This is an account that has access to the Amazon cloud, and when you first log on, well, you get access to AptiTune GO and the AptiTune user guide. You can read the user guide online, but you can also download it from our site. If you are using it online, it counts against your tuning credits, so it's wiser to download it and to read it offline. Now, if you then go, the first screen says, please wait, we are getting things ready. Sometimes this stays here for a while, and sometimes it's that fast that I'm not going to see it at all. So I am here, I say continue tuning, and here AptiTune appears, and we can start tuning just as I demonstrated before. So this is what it takes to go to the cloud. Now let me pick up my slides. I talked about sessions and timekeeping. One thing that is good to be aware of, if you close the session or if you close the browser, leave the session open, it will close automatically after 15 minutes. If you come back within 15 minutes, the session is still there, but if you want to avoid that, you can log off explicitly and then the session ends immediately. The time keeps running from the moment that you press this continue tuning button that I showed. That's when the time also appears. You have this much time left, and it stops when you log off again. So how do these two tuning offerings compare? There's a lot of similar functionality. Actually, there are more things that are identical than that are different. You can use single loops, interacting loops, cascading loops to tune them in AptiTune. You can specify constraints on the closed loop behavior in engineering terms. There's support for all common DCSs. And a feature that I didn't demonstrate, but you can export a PDF that documents your final tuning, the specifications you gave, what the initial tuning was, along with plots. So there's documentation of results. What I didn't stress is obviously there is no OPC connectivity from the cloud. There would be something very wrong if Amazon's cloud computers could access your OPC server, so that's not going to work. You need to upload files containing the step identifications. Alternatively, if you have another modeling package, we can also import models from different packages. And as a wider example of no OPC, or a wider case of no network access, not only can you not reach your OPC server, but you can't reach file shares or other stuff on your local network from the cloud offering. You can exchange information through this uploading and downloading of files. I only showed uploading, but you can also download files from there, but you can't reach other computers. The other thing is, which is an advantage of AptiTune GO, the software is updated automatically for you. If you are current on SMS, you have access to updates for AptiTune that we distribute every quarter, but you still have to install them or have somebody install them for you. Inca AptiTune GO is always up to date. And another difference between AptiTune GO and AptiTune is your data for AptiTune GO is private to your account in the cloud. The home folder that I showed, only your account can access that, and Amazon obviously has access to it. So other people can't use it, but your data is in the cloud, and you can only get it from the cloud when you are logged on to this AppStream session, because only then this up and download functionality is available. Another thing which is important to mention is the projects that you save in the cloud. If you download them, you can open them in the desktop version in AptiTune and the other way around. So if you start tuning in the cloud, but then later you find yourself being a heavy-duty user of AptiTune, you want your own standalone versions, the projects you saved in the cloud can be opened and continue to be processed in your standalone version of AptiTune. That concludes my demonstration. I saw from the corner of my eye, I think that a few questions have come in.
Yes,
Christian?
indeed. First of all, Leon, thank you very much for the presentation. A couple of questions already came in, but in case you have more questions, please use the chat box bottom right of your WebEx screen to ask for questions. Yeah. So, but let's already go over the ones that have entered. First question is, will regular AptiTune, be discontinued?
No, we have some features that I'm not going to talk about right now, but upcoming later this year, we very much intend to continue both AptiTune and AptiTune GO, and have the two to be on par as far as features go. So this is definitely not a move away from the regular AptiTune. This is a move to make AptiTune available to people who are not such heavy users that they can justify the cost of AptiTune.
Okay. Then about security. So yeah, is my data safe because the cloud?
Yeah, let's approach that from a couple of angles. Behind the scenes, Amazon is storing your data in a service that is called S3. Well, that's a technicality, but the main thing that's important here is that storage is used for lots of data by lots of companies, and although Amazon is rather secretive about the way they do things technically, it is safe to assume that the data there is encrypted so that it can't leak, and that the access to the data is also very well protected. You have your own role to play in that part as well. Don't use a password to access AptiTune GO that you are also using for other things. Don't use a true trivial password. But as far as the protection from Amazon goes, the Amazon cloud hosts company internal data of several of our companies, which is to me a testimony that the security must be pretty good. There's another angle to the security. Is my local computer at risk when I access AptiTune, or when I think I'm accessing AptiTune but somebody else is pretending to be AptiTune GO? Well, you are accessing a service through a browser, and well, the regular precautions apply there. Make sure that the connection is HTTPS, that it is really Amazon, that not somebody else is imposing there. But if you are allowed to access safe sites through your browser regularly, the risk of doing that is the same when going to AptiTune, as somebody else can pretend to be Amazon, but you can detect that by using HTTPS and paying attention to the certificate sign that is shown there. So the data is safe from both angles. Amazon has taken good care of that.
Okay, good. So in the meantime, please, if you have more questions, write them down in your chat box that you have there, bottom right of your screen. One that just popped up is are backups made of the home folder? Yeah, so it's...
Yes and no. The availability of the home folder, that's or the data in S3 in general, and as an extension the home folder, that's something that Amazon promises to be 99 dot and then a few nines more % of the time available. So and they do make backups to make that happen. So your data is going to be there. You don't need to worry that due to a disk crash or something, your data is gone. But that's not the only thing why you would want to make a backup. If you delete a file and then come to the conclusion, I did not want to delete that file after all, Amazon does not provide a service that gives you last week's version of the file back. So if you want to have that level of protection, you need to download the files yourself and keep separate copies of them. But backups to the extent that data is not lost if you don't explicitly delete it, that is taken care of by Amazon.
Okay, good. Yeah, it looks like a yes or no question, but can I use zip files?
Yeah, it can be useful to use zip files if you want to upload a couple of files in one action. But the benefit of that is rather limited, because as far as uploading goes, you can select a folder and upload the whole folder in one go. Downloading of files, it doesn't allow you to select the folder. If you select the folder, you enter the folder, but you can't download the whole folder. So a trick that you could employ there is from the file open window of AptiTune. What you see there is actually a trimmed down explorer of windows. You can select a folder there or multiple files and say send to a zip file. That creates a zip file there, right there. And you can then download that zip file to fetch the data using this cloud icon that I demonstrated earlier to upload and download files. As I said, this is mostly relevant for downloading data. But when you are downloading your project to keep a copy of it, it's important to remember that AptiTune stores its data in two parts. There is the APT file, the project file, but there's also a folder by the same name with an underscore data attached to it that contains the files, the representation of all the variables. If you only take the APT file but not the data folder and you then trend your signals, all signals will be zero. So if you make backups, make sure to include those as well.
Okay. Good. It's now 22 minutes past noon here in the Boxtel office in the Netherlands. So I think we are going to call it a day. So thank you very much, Leon. So I will make a PDF file of the presentation and then I will send it around. Probably today or maximum tomorrow, the presentation will be put on our YouTube channel, so it has been recorded. So we will make an MP4 file of it and upload it to our YouTube channel so that later on you can look at it again, or you can even share it, and that's what I hope that you will do with your colleagues. We already have a title and a date of our next webinar. It's May the 8th. It's again a Tuesday at 11:30 as usual, Central European summertime, so watch out, summertime. It will be presented by Sam Dallowell, the Managing Director of our UK office, and the title will be Breaking a Level in APC, Do or Don't. Yeah, the abstract is over there, so please have a look at it, but I will send you the presentation later on. So it is really an APC webinar about the structure of APC applications for instance, distillation columns, ethylene crackers, and so on. So highly specialized, but I think very interesting for most of the people which I see here in the attendee list of today. So for now, thank you very much for your attention. If you have any questions which pop up later on during the day, please don't hesitate to send an email to me and you will get a personal answer from Leon. Yeah, so and for now, thank you very much. Have a nice day and see you soon at the next webinar. Bye-bye.